Hello everyone, this is Chirag Sharma from International Institute of Professional Studies (DAVV). This video presentation is part of my college assignment of Information Security under the guidance of Dr. Shaligram Prajapat sir. Today in this video presentation, I will be solving the test 1 of Information Security. So let's get started. So our first question is, there are three basic approaches to authentication of a user. First one is a unique characteristics of a person such as voice or fingerprint. Now, second is an item that the person has such as machine readable badges and keys. Third is a procedure that the person knows such as password. So our first part of our question is, if the password is increased in length, it is more secure against the threat of an interpoler attempting to discover it by brute force attack. How much time will it take to break a password in this way? So our correct answer would be 1 by 2 into number of possible passwords into time to enter one password. Now moving forward to our next question is, that is, if the data entry and transmission rate is T characters per minute, the number of characters involved for entry and replying in a login attempt is L characters. The length of a password is X characters and the number of letters and numerics from which the password is selected is N characters. Then the time to break the password will be, answer is 1 by 2 into N to the power X into L by T. Now next question is, calculate the expected safe time if brute force attack is carried out by 2D working at a keyboard with the data entry rate T is equals to 120 characters per minute. The character set size N is equals to 20 characters. The password length is 6 characters and the number of characters L in the login is 15 characters. So correct answer is 1 by 2 into 206 into 15 upon 120 minutes is equals to 4 into 106 minutes. So the answer is 7.6 years. Now the last question of first question is, calculate the expected save time if the exhaustive search is added by two machines in parallel for the above data in point C. So answer is, if two machines are working in parallel, then twice as many passwords can be cracked in the same amount of time. Therefore, the expected time to crack the password using two machines in parallel would be half the time it would take with only one machine. So that's all about our first question. Now moving to our second question, that is, illustrate the public key implementation of Rivest Shamir and Alderman with P is equals to 7 and Q is equals to 11. So our answer began with the step 1, that is the two prime numbers P and Q are selected as P is equals to 7 and Q is equals to 1. Step 2 will be, then the two numbers N and R calculated as N is equals to P into Q, that is 7 into 11, that is 77, and R is equals to P minus 1 into Q minus 1, that is 6 into 10, and the answer is 16. Step 3 would be selecting an integer E, where E is less than R and E has no common factors with R. So suppose we are taking E is equals to 37, and step 4 is calculating the integer D, where E and D equals to 1 mod R, that is equals to 1 mod P minus 1 into Q minus 1. So our solve next step is 31D is equals to 1 mod 60. So answer is D is equals to 13. Step 5 is the decryption key is the secret key is 1377 and the encryption key, the public secret key is 3777. So that's all about this video presentation. Hope you all liked it. Thank you.